Hello everyone and welcome back to the Flying Sandal channel. It's great to see you again. Today we're going to continue our series where we're building the RMRC Anaconda into a fully capable vehicle with a flight controller in it. We talked about the cube, so this is what's going to power our Anaconda in the sense that it's going to allow for that stabilization, flight stabilization, return to home capability, and actually quite a bit more. Now, typically, one of the things that you want to do is you want to be able to have other functionality with your vehicle. Meaning, do you want to be able to monitor the vehicle as it's flying and you want to see it on a map on a ground station? Then you're going to need one of these. This is a telemetry radio. It uses a good deal of power. Do you want to have an FPV feed coming back to your station so you can actually see what the plane is seeing from the air? Then you need something like this. This is a DJI air unit, and this one also uses a good amount of power. And so you need to be thinking about how you're going to power everything when you put your vehicle together. Otherwise, when you're in the air, you might have a brownout, and a brownout is bad news because this thing could shut down and then your plane could come down to the ground. So we definitely want to avoid that. We don't want to have a disaster because of a power issue. So stick around. Today we're going to cover a topic that I don't think is covered enough: how to power your flight controller and all your electronics safely so that you make sure that your pieces of equipment is getting all of the power that it needs. So stick around. We're going to have a good conversation. Excellent. Thank you for sticking around. So let's get started with this conversation. And again, this is a topic that I don't see covered enough in all of the information I see out there. It is definitely covered in the ArduPilot wiki. However, I've read that wiki before and it didn't all click immediately to me. So I think that had I had someone explain it to me a little bit better and a little bit more, just showing me examples and showing me the components and why something would be powered a certain way, that would have helped a lot. So that's what I want to do for you today. I want to show you that. And also towards the end of the video, I'm going to show you also just a way of how to mount everything into the Anaconda. If you look at the vehicle, one of the challenges is that there isn't a lot of places to put things. It's very big and cavernous. You can almost hear your echo in it. However, there aren't many places where you can install things. So I'll show you that at the end. Okay, so for now, let's just have the conversation about the power of some of these components. So I gave you a little bit of a teaser that, the telemetry radio uses a good deal of power, and so does the DJI Air unit. So let's look at that in a little bit more detail. Preparing for this video, I looked up some of the power requirements, and so I have my notes here, which I'll just read to you. The RFD 900 Plus radio that I'm using here, it's a telemetry radio from a company, RF Design in Australia. Anyway, this is powered with 5 volts input power and around 800 milliamp hours of power consumption. So that's close to 1 amp hour. And that is way more than you would ever want to pull out of the flight controller directly, right? So if you're powering your flight controller from these two ports here, whatever you plug in here can get 5 volts. However, you should not be pulling a great deal of current from this board or from the flight controller itself, because the traces, all the internal components are not made for powering high-powered devices. So what you need to do is you need to power it separately, and that's, for example, what this little board does. So let me show it to you. It's a breakout board that basically what you do is you sit the modem into it, and it has these pins. So basically the pins of the modem connecting to that, and that gives you a breakout. The breakout then lets you plug in this little cable, so nice and easy connection, no soldering for it. And then it has this little lettering here, hard to read, but it just says EXT power, and basically that means you can supply external power through these 3 pins. Only the bottom 2 are active, and you have a ground and a 5 volt. And that's where you want to put the extra power. And so the way to do that, for example, where did I put it? Here I have a UBEC, okay? And I'm going to use it to power the flight controller. And for powering, the actual telemetry radio, I have these two wires that I pre-crimped, and these are gonna take just a little DuPont connector to connect here, power and ground, like that. So we're gonna look at that in a little bit more detail here in a few minutes, but basically that's the way this is going to get power, and that's gonna be the basic principle for powering everything else. So same with the DJI Air unit. The DJI Air unit gets power from 7.4 to 17.6 volts. That's basically 2 to 4S LiPo and uses about 1 amp. So if you're going to power it directly from the battery, then from a 2 to 4S LiPo, then you probably don't even need that. But if you're sharing the battery with the ESC and the servos, the parts of the system that are the dirty power, then you probably want to have a regulator. And that regulator needs to be able to provide enough power. So this unit uses about 1 amp of power, 1 amp hour. And so I did the same thing. I basically made this little harness. It has 6 wires. I'm not using all 6 wires. The last 2 are for using the DJI remote, which I'm not using. But the first 4 are for power, ground, and then RX and a TX for a UART that you can use to connect to the flight controller. So I've extended those 4 wires. That's what I've got here. I've got RX, TX, and the power and the ground. So that way I'm going to be able to power this separately and feed it up to 1 amp of power that it needs. Okay. Now, I want to show you then what this power system, this power setup that I've designed is going to look like. I made some notes, but obviously I cleaned them up later. But basically one thing to note, and we're going to see it when I show you the diagram on the computer, is that here's the motor, here's the ESC and the servos. This is considered the dirty power. And down here for the video transmission and the telemetry radio, I want to give them cleaner power. So I'm going to be using a separate power distribution board. This one here. This one is from Maytech. It's designed for quad rotors, but it's going to work just fine. It has a 5-volt output and a 10-volt output, which are going to work great for those 2 components that I told you about, the telemetry radio and the DJI Air unit. Okay, so let's go to the computer and let's show you exactly what my little diagram looks like and some thoughts and observations about it. Here we are at the computer. So let's just start our browser, and here's where I have this diagram that I was talking about. Okay, so I realize that this looks busy, okay? But let's focus on the individual components one by one. Obviously, you're going to need some power source, which in this case, it's these batteries. So what I'm going to put in the Anaconda is 2 6S LiPos, 5,000 milliamp hours for a total of 10,000 milliamp hours. Now, what you do is you use one of these power modules, is what they're called. And these are made specifically for the Cube and for ArduPilot. They come with a little wire that you connect into one of the power ports of the Cube. So that's the first way that you power the Cube. Now, it has a power sensor and a voltage sensor. By power, I mean it has a current sensor, okay, and voltage. And the combination of that, Ohm's law, tells you that voltage times amps equals power. So that's how you also determine how much power in terms of watts the vehicle is using. Okay, now let's go over this side. Basically, what I want to do is provide that clean power, right? And if you notice, from here, there's going to be a connection to the ESC, to the motor. So that's where the quote-unquote dirty power begins. And the ESC is going to also provide output voltage for the servo rail, right? So this gets connected to channel 3, which is your throttle channel, and it goes into the servo rail at the back of the Cube. And that servo rail is where we're going to be actually plugging in the servos. So that's all going to provide power to those. So we'll come back to how much power those are going to need. But we're also going to split the power here right after the power module. So we want all of the power to go through the power module. And when that sends the information to the flight controller, we're going to be able to tell the voltage of the vehicle and the current utilization. So those are very critical values to have, because the voltage tells you how much battery you have left in terms of voltage. You know that a LiPo battery is fully charged at 4.2 volts. And when you discharge it, you want it to come to a resting voltage of about 3.5 volts per cell. You can go slightly lower, but definitely never under 3 volts per cell. So you're monitoring the voltage on an ongoing basis. And when batteries are under a load, the voltage will sag down a little bit. When you stop demanding power from it, and you can do this in the air, when you lower the throttle, the battery will bounce back and give you a voltage reading. And those are really good indications for how much battery capacity you have remaining. But that's not the only way we measure battery capacity. We have the current. And also, if we calibrate that power module correctly, it's going to show us how much current have we used. So that's like your fuel gauge. The current utilization lets you monitor, and you never want to drain your batteries fully. You want to drain only about 80% of the battery. And so let's say you have a 10,000 milliamp hour battery capacity, so you want to go down to as low as 2,000 milliamp hour remaining, and so that 8,000 is what you have to use. And so you measure that voltage and you measure that current using these power module. So very important that it's there. It's very important that it's the first thing that power goes through, so you can measure the power consumption for the entire vehicle. Okay. The next thing here is we're going to break out that power. Some of it goes to the ESC, like we mentioned, and some of it goes to this power distribution board. Now I'm using this 6S PDB from Maytech. It's designed for quadcopters, but that doesn't really matter because what I'm going to use from it are these two BECs. So we're going to have a 5-volt BEC to power our telemetry radio, which I mentioned uses around 800 milliamp hours worth of battery. And so we're going to have some extra capacity there, which is great. You want a little bit more ability of the UBEC or BEC to deliver power and to have some headroom, some wiggle room in there for your device. And then we're going to use it has two, basically each one of these components here are the battery eliminator circuits. And so the second one is a 10 volt. And we're going to use that to power the DJI air unit, which is going to use about 1 amp. And this one will take from 7.4 to 17.6 volts. So 10 volts is going to be perfect. It's going to give us a nice steady quality. And if you notice in our video, because we're pretty much only doing that with this board, we're going to be avoiding all those power ripples that you get from all the motors on the airplane. Now, I am also going to get power to this secondary BEC, and that is going to be my redundant power supply into the cube. So I am going to have 5 volts from the main power module and 5 volts from the secondary BEC powering the cube. So we're going to have 2 sources of power in case one were to fail. If this one were to fail, it would still provide power to this board, and then this will be able to provide power to that to the cube. So we have redundant power. Okay, this is almost a side note, but once you power the cube, we're going to be able to power something like the Crossfire diversity receiver directly off of the cube. This uses some power, but not that much, and the power that comes from the cube is going to be enough to power that. So receivers are typically not a big concern. You can power those directly from the cube. Okay, so now that we talked about the quote-unquote clean part of the power, here's the dirty part of the power. We're going to split, like we said, the power go to the ESC. Now this is a 60 amp ESC powering the 3520 kV motor at full throttle. And I'm going to show you where some of these numbers are coming from. At full throttle, we should be consuming under 60 amps. So that's a little bit close to the limit. I would have preferred this to be more like an 80 amp ESC. But once we start flying it and we see what kind of current measurements we get, whether we actually need to get a bigger ESC or whether that one is fine. The plane is hardly ever going to be flown at full throttle. That is just too inefficient. So maybe at less than full throttle, we're going to be getting more like 30 amps of power draw, which should be well within the range for that ESC. Okay, so that's going to be powering the actual motor, the actual propulsion of the airplane. Now, the ESC has a power connection, but it also has a signal connection. That signal connection is represented here by these 3 wires. So we're going to get a ground, a power, and a signal. Now, the ESC actually has a battery eliminator circuit as well. And that's what you use to power the servo rail. The servo rail are these connections that you can see here at the bottom of the cube. and basically are the three connections that you typically have of any receiver type connection, right? The difference is that in an airplane, typically the ESC comes with a built-in BEC that is used to power the servos and the receiver. And so that's what we're going to do and take advantage of it, because this particular ESC comes with an 8 to 20 amp BEC. I believe it's 8 amp continuous, but it can go up to 20 amps on a short burst. So 8 amps is going to be plenty for us to power the flight controller and the servos. So I did just say flight controller because this actually allows or provides a third power input for the cube. So the cube should just not run out of power. We have two BECs plus the ESC's BEC also powering the servo rail, because the cube can take power from the servo rail in case that it were to lose the other power supplies. So as you can see, we always want to make sure that the cube has very little chance of losing power. Okay. So anyway, having said that, 8 to 20 amps. Now that's going to power the servos. The Anaconda uses, actually I have 6 servos here, and I forgot that it uses one more servo for steering. But it uses 4 servos for the wing, 2 for the tail, 1 for steering. When you have a servo in a stalled situation, meaning for whatever reason the servo fails, the gears get stuck, or the control surface gets stuck, that's called a stall condition, and that's when a servo would pull more current than normal. And that can be up to 800 milliamp hours. So when you're actually actuating the servos, they pull a little bit more power than when you ask them to just hold position. They use less power then. But still, you want to have a good amount of power available to the servos at the proper voltage. In this case, 5 volts for all these servos. And that's a way to ensure that you're going to have enough power to power the servos, that even if you're actuating all the servos at the same time, you're going to have enough power, and you're not running the risk of browning out any other part of your system. Okay, so this is the main diagram, the main thought process and explanation that I wanted to give you as to why is it important to think about how you're going to power your electronics. Even for a, let's say you have a good size RC airplane. Let's talk about maybe a 60-inch, which I have a 60-inch laser. If you want to wire it properly and make sure that these servos are going to have enough power, you know, like an aerobatic type airplane uses a lot of power for those servos. Bigger airplanes with bigger control surfaces sometimes use 2 servos per control surface, right? Like 2 for each aileron, etc. Whenever you have a situation like that, you want to make sure you're managing power for the servos separately. That's good practice. And that is a way to ensure that all that power draw, A, is met sufficiently, and B, is not going to be causing any issues or browning out your receiver or any of the other electronics you actually need to fly the plane. Okay, so this is the main diagram. This is the main thought that I wanted to show you. I guess one of the things that I should mention is that the cube, I told you that it's able to get power from the servo rail. The opposite is not true. It does not provide power to that servo rail. So if you don't connect, for example, an ESC that has a BEC, and you connect what is called an opto ESC, then you go into the flight controller and you're in autopilot and you're configuring, and then you go to move something with your radio controller and nothing works. And that's because there's no power to the servo rail. So you have to actually, into one of these empty slots, into one of those pins, you need to actually connect power and ground, and then that's going to power the servos. This signal will be coming out from the flight controller, but once you provide the power, then your servos are going to respond. Before that, they will not. And I'm thinking of doing that and showing you that during one of the build videos that we're going to do a little bit later on in this series. But just keep that in mind. The flight controller is able to grab power from the servo rail if necessary, but it will not provide power back to it. Okay, so that's one thing to keep in mind. I know a few people that have gotten confused by that and sounded a little strange, but that's one thing to keep in mind, that with big sock-based flight controllers, do not power the servo rail unless you specifically do something to power it, right? Some of them allow you to bridge it, some of them come with a little jumper, etc. But unless you do any of those things, the cube will not power the servo rail. So one of the things to keep in mind. Okay, so let's get out of the computer for some closing thoughts. Well, there you go. Those are some of the main ideas, some of the main thoughts about how to properly power your UAV, your airplane, or even a drone with a flight controller, and the way to do it properly and correctly so that you don't end up consuming so much power that you're browning out your flight controller. So you definitely don't want to do that. Okay, so I told you that I was going to share with you some of the tips and some of the things that I'm learning on how to actually install some of these components into the Anaconda, because there's a lot of room in there, but not a really good way to attach things to it. So let me show you one of the things that I'm doing. So I went to Thingiverse, and for the 30 by 30, it's actually 30 and a half by 30 and a half PDB, what I did is I 3D printed this little support base. Caught a hair from the dog, probably. And anyway, the way that it works is that you just kind of put it there, and you see you have a little bit of a gap. So that those little gaps are great because that means that you're going to get a little bit of air. So that's how that would mount there. And then I got these standoffs. And these standoffs are just, I got a case, like an assortment of little standoffs from Amazon. And these are what I'm going to use to just kind of hold the flight controller in place. Sorry, the PDB in place. And then give me a place to mount the telemetry radio itself. So the telemetry radio, I designed this little plate. The idea for this is that it goes on top of those standoffs like that, and then gives me a place to attach the actual telemetry radio. And that is what I'm going to be then attaching to the Anaconda, to the inside of it. Okay, so let me show you. I also have a one of these shock absorbing mounts for the flight controller, and I put it right in there. Okay. Now that one right now is not yet properly installed, so let me take it out and show it to you. So this is what that is. This is also from Amazon, and what I did is I put some standoffs at the bottom, and this is going to let me see. I cut out 4 little holes in there, and this just kind of locates in there. Now from the bottom, the little the threads from these little standoffs come out, and so then what I'm going to do is I have a little plate that I'm going to put here, and then just put threads, so that then that holds the shock absorbing mount firmly inside the plane. So that's to mount the flight controller. And then this other one with the PDB, this one is going to mount right in there, right like so. Okay, so I think I do like an assembly video to just show how that's going to go in there. Okay, now I'm not going to install them just yet. The main reason being that I want to make sure that I test all of my components on the bench before I actually put them in the plane. But I just wanted to share with you that this is the way that I'm going to be mounting the electronics onto my Anaconda. And this is something that I had to figure out how I was going to do it. But this little stack, I actually have a friend, Mike, who does a lot of these little stacks, and so he was my inspiration for coming up with this little stack. And as you can see, it's going to leave some space under the PDB, and it's going to leave some space under that telemetry radio, and that's how I'm going to mount them. Okay? Alright, well there you go. Hopefully you like this video, you learned something. Like I said, I don't think this topic about how to power your electronics is covered well enough, but splitting the servo rail, powering it separately from the flight controller and from the other electronics, providing enough power to those components that draw a good amount of power, those are some of the critical ideas. So I hope you liked it. Once again, if you enjoyed this video, and obviously if you are still watching, I'm sure this is the kind of thing that you like to watch, you like to see. Please give me a thumbs up. Please give me a like and a subscribe. I really appreciate it. It means a lot. Leave me a comment. You know, any kind of engagement. It's just going to help me build out my audience on YouTube. I just started recently doing these videos, so I hope you like them and you want me to do more. So give me a little bit of encouragement. I will appreciate it. Okay? Have a great day, and don't forget to keep them up in the air. Take care. Bye.